Okay, this is section 3.2. We are verifying the properties of triangles. Okay, so basically in this lesson, what we are trying to figure out is just some common properties of triangles that once we establish now, we know will work for all triangles moving forward. Okay, so the first example here says plot points A, B, and C and join the plots to a triangle. So I've done that here, A, B, and C. Next it says verify that D, so 2, 1, which is here, 2, 1, this is D here, is the centroid of the triangle ABC. So who remembers what a centroid, how do you find a centroid? Only Ethan, yeah.
I think it's where all the midpoints meet.
Where all the midpoints meet, okay. So just joining the midpoints together?
Or where like,
So if I joined the midpoints together, I would get something like this, right?
or the vertex from one, or the median from where all the medians meet.
Yeah, exactly. So not the midpoints, but the medians. And remember what a median is? Is what? What's a median? Adrian? Remember what a median is? Ethan is saying the centroid is where all the medians meet. What is a median?
So it's 3.2. You think you have 3.1? Nah, you flip it.
No, we're on 3.2. We did 3.1 on Friday. Yep. Median?
Is the definition from the center to the vertex?
Yeah, from the midpoint to the center of the line, the opposite line to the vertex, right. So the median of vertex A would run from A to the midpoint of BC. The median of C would run from the vertex C to the midpoint of AB. Okay? So we need, first step is to determine and plot the midpoints of all three sides. So we're going to call K the midpoint of AB. So AB, this is K right here. Okay? So we need to figure out what is K. So we use our midpoint formula. We're adding the X and the Y values. So A and B, points A and B. So A is up here and B is here. Here are my 2 points, A and B. So I'm going to add those two, negative 2 plus 2 over 2, comma, 1 plus 5 over 2. So what we get is 0, 3. Okay, let's see if that lines up. 0, 1, 2, 3. It looks good to me. That's K. That's point K. Okay? Let's call it K here. K, L, and M. Okay, L is defined as the midpoint of AC. Okay, so we're going to use that same formula now, where A and C, so here's A, negative 2 plus C is 6 over 2, and then 1 plus negative 3 over 2. So we get 4 divided by 2 is 2, and then negative 2 divided by 2 is negative 1. So let's see if that looks right. 1, 2, negative 1. That looks right, and that is L. Any questions so far? Everyone's with me? Now I'm trying to find the midpoint of BC, and this one we're calling M. So we're going to take B, which is 2 plus, and then 5 plus negative 3. 8 divided by 2 is 4, and then 2 divided by 2 is 1. So see if that looks good. It does. Alright, so we have our midpoints. Next it says draw the medians AM, BL, and CK. So we're going to draw those. AM, BL, and and CK. Okay, and it says determine their equations now down here. All right, well, first we need to find the slope. We have our point for M, which is 4, 1. We have our point for L, which is 2, negative 1. And our point for K, which is 0, 3. To find the slope, we are going to do y2 minus y1. So in this case, 1 minus negative 2 over 4 minus sorry, messed that one up. 1 minus y2 minus y1, 1 minus 1. So we get 0 over 6, which is just 0. Okay, so our slope is 0. Does that make sense? We have a horizontal line. Does it make sense that it has a slope of 0? Right? Because it's rising 0 as it runs. As it runs 6. Next one, we're going to find out y2, which is negative 1 minus 5, divided by 2 minus 2. So in this case, we have a undefined slope, right? Because we have we have negative 6 over 0. This is undefined. And when we have an undefined, that means, therefore, it is a vertical line. By definition, if our slope is undefined, we're rising infinitely. As we run 0, we're going to get a vertical line here. All right. Last one, CK. So we have 3 minus 3 over 0 minus 6. So we're going to have 6 over negative 6, negative 1 is our slope. Okay. So if that is the case, if I look at my line, CK, that means I should rise 1 as I run negative 1. So rise 1, run negative 1, rise 1, and that looks correct, CK. Okay. So now to get our equation, y equals 0x plus b. I can sub either point. Let's do 4, 1 into this equation. So y is 1, x is 4, so b is equal to 1. Therefore, my formula is y equals 1. Same thing here. In this case, we have an undefined slope. Therefore, y equals undefined. So there. This equation is going to be x equals 2. Y is undefined here, so when we sub in, we're just going to get 2, negative 1. In this case, y is undefined, therefore cannot sub y value. Therefore, your formula for the equation is just x equals 2. And you can use either point to conclude that. Okay, finally, last one. Y is equal to negative 1x plus b. We can sub in sub 0, 3. So we're going to have 3 equals negative 1, 0 plus b. Okay, next it's going to ask us if coordinates of point D satisfy each equation. So we need to sub D, which is 2, 2, 1. Where do we find D? D is given here. Here. 2, 1. Okay, so let's go sub D 2, 1. Sub D 2, 1. Sub D 2, 1. Okay, so our first equation is y equals 1. The next equation is x equals 2. And then the last equation is y equals negative x plus 3. So if I sub this, I could only sub in 1 for y. So I get 1 equals 1, so that works. Here I can only sub in x, so I get 2 equals 2, that works. And here I can sub in both, so I'm going to sub in for y1. And I'm going to sub in for x2, so I get negative 2 plus 3, 1 equals 1. That works. Alright, so D does satisfy all three of the equations. Therefore, point D, which is 2, 1, is the centroid. Okay, we know that because it lies on all three medians, right? The definition of a centroid being the intersection of all three medians. All right, example 2. Verify that the centroid divides each median in a 2-to-1 ratio. Okay, so to find the ratio of the parts of a median on either side of the centroid, use the distance formula to find the length of each part. So it's asking us to verify that this centroid here divides each of the medians in a 2-to-1 ratio. 2-to-1, 2-to-1. Okay? It wants to verify that this length is half of this length. This length, half of this length. Okay? That's what we're trying to check now. Okay? If we can determine that for this triangle, then we know that will be the case for all triangles moving forward. Okay? So we need to use the distance formula. So who can tell me what the distance formula is? Someone other than Ethan. Yeah, KG.
Square root,
Yep.
bracket, x1 minus x2.
Yep.
Bracket,
Yep.
squared,
Yep.
plus bracket, y1 minus y2, bracket squared.
Excellent. Okay, so for this, the ratio of the median, the first thing we need to do is to find the distance of AD, right? Let's find AD. So if we find AD, let's go back to our triangle here. AD, we're going to find the distance here, and then we can see if it's half of this distance here. Now actually, because this is a slope of 0, right? And this lies right on the point 2, 1. I don't actually need the distance formula here, right? I can see that this is 1, 2, 3, 4, and DM is 1, 2. So AD is equal to 4, and dm is equal to 2, right? This is visual on graph. Therefore, 2:1 ratio, right? So what does that mean? The centroid divides the AM median in a 2:1 ratio. Okay, now we would have got 4 and 2 if we use the distance formula and those points, but I can just count, right? Because we know the line is horizontal, we're just along these points, okay? Same thing for this vertical one. I can see it's 1, 2, and 1, 2, 3, 4. So we can do the exact same observation with this vertical line. And we can see that the point D, the centroid of the triangle, divides this median in a 2:1 ratio. Okay? So we can say for BL, that is BL, right? Yep, BL, this line here. Okay? Same thing. I can say BD is equal to, here, BD is equal to 1, 2, 3, 4. And then DL and this is visual. Therefore, 2:1 ratio. So I'm gonna write it out. Therefore, the median BL is divided into a 2:1 ratio by the centroid D. Okay, now the last one, it's not that clear, CK. Okay, it's not a vertical or horizontal line, it's an angled line. So let's use the distance formula. So first I'm just going to put these 2 points here, I'm going to need them. So C is 6 and -3, and K is 0 and 3. So I want to get the distance, which is square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so the first thing I'm going to do, let's get D over here too. D is 2:1. Is I'm going to check the distance between D and let's do the short one first, D and K. So D and K. Okay, so my distance of DK. DK is equal to the distance formula here. So now let's use these 2 points, D and K. So square root of x 2 minus 0 squared plus y1 minus 3 squared. So this is going to be equal to 4 plus -2 squared, which is equal to 4 plus 4 square root of 8. Okay, which is actually 2 times 4, right? So I can say the square root of 4 is 2, so it's 2 root 2. Okay, if you're not sure what I did here, I just took the square root of 4, which is 2, so I can bring to the outside, 2, and then I left the square root of 2 on the inside, so 2 root 2. So this is the longer, the longer side or the shorter side? DK. This is the shorter side, DK. So now we want to check DC, and we want to see if DC is going to be twice this distance. So it should be 4 root 2. Let's see. So DC now is going to be equal to DC 2. Square root of 32 is the same thing as square root of 16 times 2, which is the same thing as 4 root 2. Now you can double check this on your calculator, but I can see here that DC is twice the distance as DK. So therefore, DC equals 2 times DK. So we get that same 2-to-1 ratio divided by centroid D. What is our conclusion here? Centroid divides each median in a 2-to-1 ratio. All right? Yep. I can't hear you. Say it again.
Can't leave it as like square root 32 or something like it's equal 4 square.
Yeah, you should put it down to the lowest square root terms, or you should just put a decimal value. Okay? Okay, it says verify line segment KM is parallel to AC. Am I missing a page here? Might be missing a page. 2.2. There's one more part to this. Hold on.
So you're going to hand it up.
Yeah. Pass me one too. Okay, we're going to go to example. Pass me one first. Okay, this one is 3.2, verifying properties of triangles. Point 2, the mid segment. Okay, so first we need to plot this. 7, 8. So if you want a hole puncher, it's here. Okay, it says join the points to a triangle. So we've done that. Determine and plot the midpoints of all three sides. So K is AB. Okay, so midpoint K is going to be equal to A and B, so we're going to do Okay.
Well, how we use this, sir?
AC. BC. All right, so I found the three midpoints here, K, L, and M. Next, it says the definition of a mid-segment is a line segment joining the midpoints of two sides of a triangle. So draw the mid-segments KM, KL, and LM. So KM would be here. KL would be here. And LM is here. Okay, so I've drawn now the three mid-segments, which is the line joining the midpoints. Okay, and use the slope formula to compare. So draw the mid-segments. So slope of Km. Km is up here. Km. So we're going to do K. Y2. (3.5/4). Let me keep this in fraction terms. 5/2. And actually, I'm going to switch these around because I had y2 in front of y1. I think it makes more sense to put m first and then k. So y2 is 5/2 minus 1 over 6 minus 1. Okay, in order to subtract these, I should get like terms. So this is 5/2 plus 2/2, because the minus minus becomes a plus. All of that over 5. So we get 7/2 over 5. Now when we divide fractions, we're multiplying by the reciprocal of the denominator. So this actually becomes 7 over 2 times 1 over 5. So we get 7 over 10. That's our slope.
Sir,
Yep.
how do you get 1 over 5?
1 over 5 here?
Yeah.
When you have a fraction divided by another fraction, which is 5 over 1, you're actually multiplying by the reciprocal of the denominator. So to solve a fraction divided by a fraction, you need to multiply by the denominator flipped. So divided by 5 is multiplied by 1 over 5. Okay? Any other questions with that? Okay, so that's our slope of Km. Now let's do the slope of AC. Okay, so here we have AC, so y2 is going to be A, and y1 is going to be C, so we're going to do A as the second one, so let's do CA. C is negative 3, 1, and A is 7, 8. So our slope y2 is 8 minus 8 minus 1. Don't have a lot of space here. 8 minus 1 over 7 minus 3. So we get 7 over 7 plus 3 is 10. Oh, look at that. These two slopes are the same. So the slope of Km is equal to the slope of AC. Okay, so what is the conclusion here? Km is parallel to AC.